We are halfway through chapter 2. We studied lessons 1, 2, and 3 last week. This week we're going to study lessons 4, 5, and 6, which are about some pairs of angles and also perpendicular lines and things we can know about those. And still building in this idea of proofs. So I think in tonight's homework there's maybe only 1 or 2 proofs and they're fill in the blank. But as we progress through these 3 lessons, we're going to be building towards actually being able to write our own proof, following a logical progression from one step to the next step, and building and asking ourselves questions like why and where can I go from here, or what does that mean? But for today, you're still going to be looking at fill in the blanks on your homework. So today's lesson is mainly about special pairs of angles. So complementary angles is a pair of angles, just 2. You cannot have 3 angles that are complementary, okay? Complementary angles are a pair of angles, 2 angles, who add up to or have a sum of 90 degrees. Supplementary, 2 angles that have a sum or add up to 180 degrees. Students often get this confused as to which one is which, complementary and supplementary. So one way to try to remember it is alphabetically. C comes before S and 90 before 180. Okay, so complementary is 90, supplementary later in the alphabet brings in the 180. One way to maybe try to keep them straight, which one is which. Complementary adds to 90, supplementary adds to 180. Our third type of special angle pair for today is called vertical angles. The definition of vertical angles tells us what they look like. It's 2 angles so the sides of one angle are the opposite rays of the other. So we learned what opposite rays were in chapter 1. So if I look at angle 1, the sides of an angle are 2 rays. We learned in chapter 1 that opposite rays complete a line. So I can draw in those opposites, which would complete the line, and angle 1 and angle 3 are vertical angles then. Vertical angles are angles that are across from each other diagonally when lines intersect. Okay, so our definition of vertical angles tells us where to locate them. That when lines intersect, they're the angles that are across from each other diagonally, or that their sides are opposite rays. Questions on any of those 3 angle pairs? Complementary, supplementary, vertical. We have a theorem about vertical angles that tells us that they will be congruent, or that they will be the same size. We want to prove this theorem. So we're going to prove it together. Not fill in the blanks, so we can kind of build this idea of asking ourselves a question of, so where do I go from here? So what now, or what does that tell me? Almost always, we start a proof with the given. In this problem, our given is really just a picture. It's just as shown. So if all we have is a picture to start with, that's not going to be something that's actually in the body of our proof then. So this is one of those rare exceptions where the first thing we do actually can't be a given, because the given just says, look at the picture. So we are going to start by saying the measure of angle 1 plus the measure of angle 2 is equal to 180. The measure of angle 1 plus the measure of angle 2 is equal to 180. Why can I say that? If we look at the picture, what am I doing when I put together angle 1 and angle 2? Angle addition. There are 2 angles that are adjacent to each other. They're right next to each other in the picture. And they're combining to make a straight line.
Could your proof also be definition of a supplementary angle?
We can't use a definition of supplementary here because we weren't told that they are supplementary. So to use that word, we would need to have already had that word in the problem.
Okay.
They are supplementary, but we weren't told that. In step 1, we added together angle 1 and 2 and got 180. Is there anything else I could do that's pretty much the same thing and then I can just do it in the same step?
4 plus.
I could do 1 and 4 together, and that would still be 180, and it would still be angle addition. So we can do that all in the same step then. You can do more than one thing in the same step as long as the reason is the same. So in step 1, I want to do 2 angle additions here. Adding together 1 and 2, and adding together 1 and 4.
How do you come up with what you want to do to solve it?
Practice. Yep, that's the hard part about proofs is I really wish I could tell you guys like step 1 you do this, step 2 you do this, and just give you like a list of rules, but it doesn't work that way. So it's just kind of practice, and the more we practice together, the more comfortable we get. I know that's not the answer you want. It's not the answer I want to give, but that's the true answer. So. All right, so in step 1, I said angle 1 and 2 put together is 180, and angle 1 and 4 put together is also 180. So what could I do with that information to kind of condense it? If 1 and 2 equals 180, and 1 and 4 equals 180.
Get rid of.
Oops, this should have been plus here.
Get rid of the angle 1.
I will want to get rid of angle 1, but I can't just get rid of it yet. If 2 things are equal to 180, what does that mean about them? They're equal to each other. So I can say that 1 plus 2 is equal to 1 plus 4. Since they both equal 180, they must be equal to each other. What is that called?
Substitution.
Substitution. We replaced a 180 for some angles instead. Now you guys were thinking ahead and saying, well, we're going to want to get rid of some angle 1s, and that's what we're going to want to do here. If we always keep in mind our destination and what we're trying to prove, that will help guide us through a proof. So if I look at what I'm trying to prove here, I'm trying to prove that angle 2 and 4 are the same size. So at this point, I have 2, I have 4. They're on opposite sides of the equal, so that's good, but I got this angle 1 in the way. So what can I say about angle 1? Reflexive. It's at least equal to itself, if nothing else. And then if I think about steps 2 and 3 like an algebra problem, you guys said I would want to get rid of angle 1. What kind of math is that that gets rid of it?
Substitution.
So if I look at those two like an equation, what am I doing to the 1 on both sides? To get it to go away, I'm subtracting it. So that's our subtraction property of equality. And that got us down to 2 and 4 being the same, which is what we were asked to prove. So this theorem says that vertical angles are congruent to each other. The definition just tells us where to locate them, that they're across from each other diagonally. This theorem tells us that they are actually congruent. This is a really important idea that we're going to use for a very long time. This first semester is going to be highly cumulative as we move from chapter to chapter. We're building up all these ideas that we can combine now, and as we move through, we're going to keep on talking about vertical angles for a long time. It's going to be important to us that vertical angles are the same size. Questions? Okay, the next problem says a supplement of an angle is 3 times as large as the complement. Find the angle. We have 3 different main nouns here. The first thing we're talking about is an angle. We don't know how big it is, so I'm going to call it x. The second main noun is the supplement. If, for example, our angle was 100 degrees, how big would the supplement be? 80, because supplements add up to 180. If our angle was 30 degrees, how big would the supplement be? 150. What are you doing to figure that out? Subtracting from 180. So whatever our angle is, if we subtract it from 180, that gives us the leftovers to come up with how big the supplement will be. So however big our angle is, the supplement is the leftovers of the 180. The third big noun in our problem is complement. So if our supplement is 180 minus x, what should our complement be?
90 minus x.
90 minus x, because complements add up to 90. So now that I have my nouns defined as symbols, I can rewrite these words in symbols. So a supplement of an angle, that would be 180 minus x, is, in math, is an equals 3 times, so 3 multiplied by something as large as the complement, 90 minus x. Questions on how to come up with this statement? Okay, we want to define each of our nouns as symbols and then work our way through replacing words with symbols. So our supplement we said was 180 is equals 3 times or 3 multiplied by what we defined our complement as being. Then it says find the measure of the angle. So now we want to solve for x. What's my first step in solving for x?
Distribute.
Distribute the 3. Then there's a lot of things you could do next here, and it's mainly preference. Any one of those 4 things could be added or subtracted to both sides. My preference is moving variables first and doing so in a way to try to get them to be positive. So I'm going to choose to add 3x to both sides. But that is totally a preference. Any one of those other things that you might move around the other 3 things is totally okay to do. So I end up with 180 plus 2x equals 270. So then I want to try to get x alone. I got to undo what's being done. So I would subtract the 180, which leaves me with 2x equals 90. And how do I finish to get x alone? Divide by 2 gives x is 45. Whenever you finish a word problem, reread the problem, or if it's under a set of directions, reread the directions to make sure that you've answered what you were actually asked for. So this question says, find the measure of the angle. If I look up at the top at what I defined things as, I said x was the angle, so I'm good. Because I found x is the angle, that's my answer. You will have some problems similar to this in your assignment, but some of those ask you to find the angle and its supplement. So then we would need to make sure we give both of those answers. If I needed to give the supplement or the complement here, now that I know x is 45, I could replace that and find our supplement is 135. Okay? Or likewise for the complement. I can plug in what I got for x and find our complement is 45. Okay? So make sure that you reread a word problem or directions when you think you're done so that you know that you actually did everything you have to do. Otherwise, you'll lose a lot of half points on the homework if you're missing parts of the answers. Okay. Questions? In the diagram, angles 4 and 5 are the same size or congruent to each other. Find 2 other angles that are the same size as 5. What is one other angle that will be the same size as 5?
7. 4. 8.
Okay, 4 is given. 8 will be. Why are 5 and 8 the same size? Because they are vertical angles, and we'd assume that said vertical angles are congruent. What's one more that will be the same size? 7. What is 7 vertical to? 4, but 4 is the same as 5. So that's what we call a transitivity. When we can set up 4 and 7, but 4 and 5, and end up with 5 and 7. When we can say this equals this, which equals this, which equals this, that's called a transitivity. When we can set up a chain of everything being equal to each other. Our directions here ask us to find. Our directions here ask us to find the measures of the complement and the supplement given a certain angle. So if my angle is 75, how big will the complement be?
It is
15. What do we know about complementary angles?
You need to add up to
They need to add up to 90. So our complement would be 15 because 75 plus 15 equals 90. What about our supplement?
105.
105, because supplementary angles need to add up to 180. So 105 plus 75 equals 180. The next problem here is the same type of thing, but instead of giving us a number, it just gives us a y. So if I don't know how big the angle is,
180 minus y.
the complement will be what? 90 minus y. And the supplement will be 180 minus y. Okay? So in general, if we're looking for a complement, we can subtract from 90. In general, if we're looking for a supplement, we can subtract from 180. In this picture, we want to name two right angles. So where is one right angle in this picture? LMP. LMP, we can call LMP, we can call it PML, or we could actually just call it angle M, because that's the only thing going on over there. So if there's nothing else going on there, we can name an angle just by its vertex. So angle M is an acceptable name for that angle. However, like angle P is not an acceptable name because there's lots of different stuff going on down by P. Okay? What is the second angle in this picture that is a right angle?
QPM.
Okay, QPM or MPQ I heard as well. Either way is fine. But putting together those two angles in the corner going from Q through P up to M, that whole corner is 90 together. Remembering that angles can be a combination of smaller angles. Our next one says name two adjacent. So then we need to remember this vocabulary word from chapter 1. Adjacent in everyday language means next to. So like my classroom is adjacent to Mrs. Nemi's classroom. Okay? It's right next to it. Okay? In angle terms, adjacent angles are right next to each other. They have the same vertex and they share a side or share a wall. So I want two angles that are right next to each other at the same corner that are complementary. What's a complementary mean? Add up to 90. So two angles that add up to 90 that are right next to each other in the same corner. Kyler?
Yeah, I'm gonna do 70.
QPL?
And LPM.
LPM. Okay. The two angles that have a corner of P, the lower QPL 40 and then the upper LPM. The two angles with the corner of P there. But we can't just call it angle P because there's too much stuff going on at P. The third one asks us to find two complementary angles again, but this time we want them to not be adjacent. So they either shouldn't be in the same corner or not sharing a wall, somehow not right next to each other, but they still need to add up to 90. So where do I find two angles in here that add up to 90?
LPM and PLM.
Okay, those have different vertices. I can tell just by looking at the names because P and L are in the middles, and that's what defines the vertex. So these are definitely not adjacent. LPM in the picture is 50, and PLM in the picture is 40. 50 and 40 together make 90. So those work out. They do still share a wall, but they don't share a vertex. So they are not adjacent. Questions? We are given in this diagram that AXB is 90. It also has a little box drawn into it. So if you see a box in a picture, you can know that's a 90 degrees. Otherwise, we don't assume and trust our eyes. We want to, in this picture, find two congruent supplementary angles. What does supplementary mean? Add up to 180. What does congruent mean? Equal. So if they are the same size and they add up to 180, how big are they? 90. So I'm looking for two 90-degree angles in this picture. Where is this one 90-degree angle in this picture? AXB. We were given that information. And where is another right angle in this picture? BXD. Because if they're next to each other on a straight line and half of it's 90, the other half has to be 90 as well. So you have to add up to a straight line of 180.
How do we get X? How do we get L?
The next question says two supplementary angles, so again adding to 180, but this time I want them to not be the same size. So not both 90s. Where do I find two angles that add up to 180?
CXD.
CXD, what goes with CXD? AXC. Okay, remembering that angles can overlap. A lot of times students don't see AXC as being an angle because that B is in the way in the middle there. But it is. AXC is an angle. Putting that together with CXD gives a straight line or 180. The next question asks for two complementary angles. What does complementary mean?
Same size.
Add up to 90. So where are two angles that add up to 90?
CXD.
CXD and XD.
CXB and
CXD.
CXD. The two angles that are over here. Because we said in the first part that that whole corner has to be 90. And the last one, a straight angle in the picture.
XD.
AX.
BX.
An angle needs three letters. So we can't define like BX as being a straight angle because that's not enough letters to make an angle. Okay? So an angle needs three letters to define it. So AXD is the only one that can be defined there. Questions on any of these? It is important that we pay attention to symbols here. These are two different types of questions. The first type of question says angle and then has a congruent symbol that equals with a squiggle. The answer we are looking for there is another angle name. Okay, so we want angle name congruent to angle name. The second type of notation says M angle, which means the measure or size, is equal to. There we're looking for a number answer. How big is it actually? Okay, so pay attention to your notation so that you answer your questions appropriately. Congruent, we should name something. Equals will give the size. So AOB should be the same size as what other angle? Angle DOE. EOD is the same way, doesn't matter. We're looking for those two angles. Why are those two angles the same size?
Because they're vertical.
Because they're vertical angles. Okay, so that would be if we needed to justify something, that would be our justification. Vertical angles are congruent. The next one, FOB. FOB is the same size as, so that's got an overlap, so we want to pick another angle that's going to be the same size.
COA.
DOC. So, vertical angles, is that not what I said? Oh, sorry, EOC, yes. I very well could have said the wrong thing. So, what I drew is right.
Could it be AOC?
I got it.
It could not be AOC.
It has to be on the other side of that.
Well, if we actually start figuring out some numbers to put in there, those won't be the same size. They look like they are, but they actually won't be the same size.
Can I get the next one?
Oh,
Yes. So, what angle, and this question has been assigned, is this, how big is FOE?
I believe it is
60.
60.
Okay.
60 degrees.
FOE is vertical to BOC, and BOC is 60. So this must be 60 as well.
Hundo.
COE.
A hundo.
So COE, I already have down here highlighted out.
1 hundo.
How big is it?
120.
120.
1 hundo.
There's a couple different ways to think about this one. The first way to think about this one is that we just said in the last one that was 60. That angle and the one now from this question together make up a straight line. Straight line should be 180, so there's 120 left to make up that line. The other way to think about this one is to start filling in all of the other missing pieces. So that missing piece on the top, AOB, should be how much? 80. Because I need to have a straight line on the top of 180 And then I can start filling in all of the pieces and add up the pieces I need, which would be an 80 and a 40, which would make 120. And the last one here in this section, DOB,
100.
100. Putting together those two pieces,
Hey,
I get 100.
my number.
The big hundo.
Questions? In this picture, we are given some information first that seems a little bit off. It says there are 4 right angles in the figure PQRS, but it doesn't really look like it. They don't look like right angles in PQRS, but the directions tells us they are. Then it tells us VTR is a right angle, but it doesn't really look like it, but it tells us it is. And then it tells us QSR is 60, which is labeled out. It is important to think about what is actually going on in this picture. This picture is a 3-dimensional picture. We can tell when we start having a lot of dotted lines in. That means we're looking at something 3-dimensional because some of this stuff is actually hiding. So what we have happening here is a rectangular base. PQRS is a rectangle on the bottom. Point V is floating up above the middle of it, connecting straight down to the ground at point T, and then going out to the corners. Okay, so it's kind of like a tent with its peak up at V. Sometimes it helps to redraw it as if you're looking onto the top of it. So PQRS should be a rectangle. Point V would be floating right above it. Point T would be there as well, because if I'm looking straight down, V is going to be right on top of point T. Okay? Then I've got this diagonal that's coming across and actually comes out to make point X. And RS continues to make point Y. Okay? And we are given QSR is 60. So I can put the 60 in there. Okay? So this is, if I was looking straight down at the top of the tent, what I would be seeing. So now, how big is VTP? So VTP, over there, it's 90. It doesn't look like it in the given picture. It looks a lot smaller, but if it's right next to another 90, it has to be 90 also. That's coming from the peak of the tent down to the center and out to the corner, which should all be right angles. XSY is happening outside of the base. XSY is 60. Why is it 60?
Vertical angles.
Because it's vertical to another 60-degree angle.
Good job, Brad.
Right.
Oh, sorry. Good job, Brad. And
RSX. So I've got RSX down in my secondary picture or in the original picture. How big is that going to be? 120. Why?
because
Because it's next to a 60 and it's on a straight line, so they have to be supplementary or add up to 180 to make the straight line. PSY. If we look at the original picture, this one tends to be rough for students. But if we look down at the second picture, how big is PSY?
90.
90, because it's coming off the corner of the rectangle. So it doesn't look like it in the original picture. But once we take some of that perspective out, then we can see that that should be a 90-degree corner.
Wait, can you re-explain that?
Yep. In the top picture, PSY looks bigger than 90. But in the bottom picture, we can see that PS is one side of the rectangle, and SY is continuing a second side of the rectangle. So rectangles should meet at right angle corners. So we end up with a 90-degree there if we look at the bottom picture. In the top picture, that's hard to tell. But because PSY is made of two sides of the rectangle, it should be a 90-degree angle.
In the picture you drew, isn't there supposed to be a line from P and R?
Yeah, I just didn't draw it because we didn't actually need it for any of the questions, so I didn't draw on the extra diagonal. But yeah, there should be another diagonal there. Alright, last question for the lesson today. Given that angle 2 and angle 3 are congruent, the first thing says, what can you deduce? Okay, the word deduce means like draw a conclusion or figure out, and we're usually thinking like the biggest jump we can make in logic. So there's lots of things we can do here, but what's like the furthest leap in logic?
Yeah, well, you can angle 1 and angle 4. Yeah.
That would be a big jump in logic to say angle 1 and angle 4 are congruent because we weren't given any information about 1 and 4. So to draw conclusions about stuff we weren't even starting with would be a big conclusion to make. So how would we do this? How could we make this conclusion? Where's a good place to start a proof? The given. We have a given here, so I'm going to start with it. If I want to prove something about angle 1, I should probably say something about angle 1. What is angle 1 the same size as?
Angle 4. 2.
Can't jump to 4 yet, but we can say it's the same size as 2. How do I know it's the same size as 2?
Because they're vertical angles.
Because vertical angles are congruent. That's what our theorem said today. You can quote this by writing VA congruent. That's a fine abbreviation. You could actually write out the words vertical angles are congruent. Please do not cite the reason by saying theorem 2-3, which is what it was, but that doesn't mean anything. So that's needless information to try to memorize. So we'll just say, how do I know it? Because they're vertical. Okay. If I want to prove something about angle 4, I should probably say something about angle 4. What can I say about angle 4?
It's equal to angle 3.
It's congruent to angle 3. Why is it the same size as 3? Because vertical angles are congruent. Now what we want to do is see,
Wait, we have done that in the same one.
we could have done that in the same step.
Same question.
Yep, because they had the same reason, we could have put them in the same step, and that would be fine to do. Now what we want to do is see, do I have enough information to be able to link up and connect what we want? So I can go from 1 to 2 to 3 to 4, and I got myself from 1 to 4, and that is called transitivity.
Transitivity. I thought that was substitution.
Transitivity is transitive.
You have to
Did I spell
have
that
a C.
You can just do trans. Transitivity is like a fancy form of substitution. So substitution would be an okay thing to say here as well. It would be totally right. Transitive is a little bit more specific. Transitive is when we say this equals this equals this equals this equals this. Substitution can be replacing just parts or pieces of a problem, but transitivity is kind of a special form
So would you
of substitution.
mark it wrong?
I wouldn't mark it wrong if you put substitution.
You would not.
I would not mark it wrong if you put substitution. Transitivity is just a little bit more specific, but it's still correct to say substitution. You do actually have homework tonight. The problems jumped up to the top of the next page in your packet. When we switched from PCs to Macs, all my margins got messed up, and I forgot to go through and fix all that for you.
There's
So
so
you
many.
do have homework, and it's on the next page.
They're spread out.